Objective number 19. Apply Newton's laws to solve problems involving normal and tension forces, including systems or objects connected by strings and Atwood's machine. Now, this Atwood's machine might be a new term to you. It's nothing but you can read about it. I've given a small snippet. George Atwood, he is the one who created this design. This you may have seen it in real life. The pulley, and then there are two objects hanging. To calculate force and tension and to verify the laws of motion of objects under constant acceleration. This is for us to study about these accelerating objects. All right, so that's a device, and the name given to the device is Atwood machine. And you should be familiar with the tension force. Tension force is the one which is acting on ropes or strings, etc. So we label that as tension force. All right, so tension is a force. Now, as you can see, 16, 17, 18, 19, so around 4 questions, that's about 32 marks, will be based on Newton's laws. So net force, identifying the Newton's third law pair, etc. would come. Let's discuss another question. That's slightly different. It's a vertical movement, and I would say this a little medium level challenge. All right, a medium level question we can label this as. So practice these type of questions and be confident to solve even if such questions come as well. Okay, all right, let's read the question. Your mass is 75 kg and you are standing on a bathroom scale in an elevator. So this is nothing but the weighing scale. We're talking about the weighing scale. In an elevator. Elevator is the lift. So starting from rest, so you're not moving initially, you're starting from rest. The elevator accelerates upward. So there is an acceleration here, upward at 2 meters per second square. So the acceleration is 2 meters per second square for 2 seconds. So the time is also given. And then continues at constant speed, after which it's moving at constant speed. So the net force would be 0 in that case. Okay. Now, is the scale reading during acceleration? So the question is very specific. During acceleration, is it greater than, equal to, or less than the scale reading when the elevator is at rest? So you might get questions in multiple choice or a writing part question. So understand, how does the weighing scale reading change in an elevator? We all might be thinking the weighing scale should always read our actual weight or actual mass, but it's not the case. It does not read the same. It changes based on whether we are applying our equivalent force or force of gravity. So if you push on it, so if you take a weighing scale and if you apply a force on it, it might read a different value. So why? It's like the reaction force. It's reading the normal force. How much force you are applying on it will be recorded in it. So let's see, in this situation, since it's going up, there is a net force acting upwards, right? There is a net force acting up. Now, when any situation, when you have, whether it's a vertical movement or horizontal movement, you will just try to identify what are the forces acting on the object, or in other words, a free body diagram that will help you even if it's not given in the question. So in this case, there is what's the force acting up? It's a tension force. We all know the lift is held by ropes inside, so there is tension that's acting up, and you have the force of gravity of the lift that's acting down. So this is also good to know that what are the forces acting on the lift itself. Okay. Now coming to this particular situation, this is the question is about the person standing inside. Okay. The elevator questions can be two types. One is about the elevator itself with the person, or just the person alone. So here the question is just the person alone. Okay, so let's form a meaningful equation for this. So upward is the tension. So in this case, will the tension, because it is accelerating up, will the tension be greater than the person's weight? If it write as a man, yes, it is going to be greater because it is accelerating up. If it is accelerating down, then the downward force will be greater than the tension. All right. So this difference is equal to the net force. So T minus the force of gravity will be equal to F net in this situation. Right. So now I change the subject of the formula. So minus Fg equals F net minus T, or Fg equals T minus F net. Okay. What is the tension force here? Is that given to you? It's not given. And Fg plus F net. Okay. Fg is mass times gravity plus F net. How do I find? Mass times acceleration. Right. So the mass is 75. So 75 times 9.81 plus mass times acceleration is 75 times 2. So that'll give you 885 Newton. So that's your total tension. So as you see, we have calculated the tension that's pulling up the elevator is 885 Newton. Now that's not the question. What they ask you whether the bathroom scale will read a value that is equal to or greater than or less than your actual weight. So let's first calculate what's the actual force of gravity or the weight due to the person. It's 75 times 9.81, which is 735 Newton. So when will this be read on the scale, when the bathroom scale or the weighing scale, when will this reading be displayed is when, if it is 735 Newton or equivalent kg, 75 kg, when will that be read is when the person is in equilibrium state. When is that possible? As we have been discussing earlier, either the person is at rest or if the lift is or the person is moving at constant speed. So the scale will be reading his original actual weight when either the person or the lift is at rest or it's moving at constant speed. When it is accelerating up or accelerating down, it's going to read either greater than or less than this value. So in this case that we have calculated, the lift is accelerating up by 2 meters per second square, and we calculated what's the total tension that's applied on the lift. So it's the reaction force that will be read on the bathroom scale, which is going to be 885, which is greater than his actual weight. Okay, the scale will read 885 in this case. And logically or in real life situation also you can connect it and remember, when you're pulled up you feel heavier, so the scale will automatically it will read heavier. So connect it like that. When you fall, when the lift like snaps or if it's increasing acceleration, when it falls down you feel lighter, and when it is almost zero, that's when you lose contact with the weighing scale will read 0. That's when we call it as weightlessness. Okay, so keep all these points in mind and practice these questions.